Hi, Algebra. All right, so first off, if you haven't taken the test yet, this is very important. You need to raise your hand right now if you haven't taken the test yet. We need to pause the video, you need to get your test, and you need to go to a different math teacher's room and take it. Super important, so go take care of that now. So if you haven't taken the test yet, raise your hand right now, pause the video, and then go take your test in a different room. Don't worry about part of the test. We'll get that taken care of when I get back on Monday. So ready, set, pause the video. All right, I'm going to assume everyone here now has taken the test. So we're going to go over the test. Some of you can see like, oh, that's why I missed that. So overall, the test averages were actually pretty high. I'm really proud of you guys. The multiple choice part had a B average, and then the graphing part also had a B average. So I would say it's probably a B average overall. It's hard to tell between both because I have it on my phone and also on the paper as well. So that's just like a rough estimate. I did have, at the end of the day, 2 people that aced it. So good job, you guys. You know who you are. Proud of you. Proud teacher moment. Also, just to fill in, I'm wearing a red shirt for Red Ribbon Week because today's Red Day. And then these are my fraternity letters. So I was in Phi Mu Alpha. I'll probably post something about that on Monday, if I remember. If not, remind me. All right, so the first part of the test was about 4.1. Graph the story shown on the projector screen on the graphing story sheet. Please make sure your name is on the graphic story sheet. I actually didn't give this to you until after we did it. I just ran through it anyway, but I wanted to actually go over them. So I'm going to hope that they show when they play correctly. That's my hope. So let's see if that works. So the first video that we watched was elevation of a plane. Maybe. This is me hoping it works. Would have been smart to test it ahead of time. Live and learn. Then get loves. Cast to a device. Open with. Open with what? Open with Windows Media Player. Let's try that. There we go. Aha! Perfect. So, I'll move me, because you know what's going to happen. Alright, so here we go. So, just talking through like what the shape of the graph looks like. You guys knew elevation in plane feet. You knew that it was going up by 2s. So then you have your graph. A lot of you guys, when you looked at this graph, you kind of got panicked because the plane disappeared behind the tree. Unfortunately, that does pose a little bit of a problem, but it does give us some information because while it's behind the tree, we can actually see it, and you notice that it goes this pattern here. So as time increases, the height of the plane first increases and then decreases. So let's watch it very carefully. So here it goes up. As he lifts it, as he throws it, it goes up in the air. It actually goes out of frame for a bit. And then it continues gliding down. And then as soon as it comes by here behind the tree, it falls down really rapidly. And then you see it hits the ground and stays at the ground at 7. So at 7, your graph is going to flatline. We're going to see this here when they show us the answer too. So I thought that was pretty cool. I like this one. This one actually was my favorite out of all of them. Just because of like how it shows it, and it kind of gives you some mystery behind the tree. But when it goes through and actually shows it, you see there wasn't a lot of mystery. It did exactly what we expected it to do. The plane fell on the ground. So over time, so he threw it up, and it went down, and that 7, or thereabouts, it stayed. And you see it doesn't go back above. So here's a few things that this is a 5 graph, obviously, that's the answer. Other 5 graphs is if you have it going up and then down. I did take that if you just, because it's hard to tell, if you just had it going straight down and then hitting the ground and then staying down, that's fine too. Anywhere around 7 was sufficient for it staying. I saw 7. It says 8. That was fine. If you had it not hitting the ground, like if you had the airplane floating, then I took a point off for that because the airplane has to hit the ground and stay at the ground. And then finally, the other things. A few people missed points for not having a 0. Everyone got a title and everyone got your y-axis label, so I appreciate that. So overall, pretty good. So that was that one. Now let's do the other one. So, fun fact about this particular one, the person that's in this video, his name is Dan Meyer, and Dan Meyer is a wonderful speaker. and one of the people that I've seen teach. So everyone had this, so I'm going to let this kind of play through. Dan Meyer swinging. So we would expect to see sort of something like this as you're going through and doing it. So here he's swinging. This is his waist. So essentially where the swing is, you're looking at the swing seat. It's going back and forth. So we would expect what's called a cyclical graph, a graph that goes up and down. This would be an example of a nonlinear graph. The other one was more linear. This one's more nonlinear. So he starts down low. He goes high, low, high, low, high, low. My head is bobbing. High, low, high, low, high, low, high, low, high, jump. So at that jump, he's actually at his highest point. And then his waist doesn't move. His waist stays for the rest of the frame. So we're going to see that in the answer too. So here it is. So up, down, up, down, up, down. A lot of you had this. If you had it so that it was bigger than what it has, then that's not a big deal. This answer is off because he actually jumped at 11, not at 8. And notice that. So don't look that far. But so it's 1, 2, 3, 4, 5, 6 times. But other than that, I like it. 5 would be this. I wasn't really strict about the number of times as long as you had more than 4. If you had at 4, then that was a point off. If you had 5, you were fine. If you had more than 8, I think I took points off. Again, some people missed the 0 down here. Everyone had this. Everyone had the title. And everyone's graph was continuous. The lowest score that I got on the graphing portion was a D. That's exciting because that tells me that you guys are experts at graphing. And then I would say probably about a quarter of you aced the graphing part. So I think that's awesome. Good job, you. So that's the graphing part of the test. Now moving on to the other part. So here, what was I just in that looked better than this? This. There we go. Looks a lot nicer. Move me over here. Whee! So we did the graphing stories. Each of those were worth 10 points. A lot of people were confused. That's 20% of your test. So those of you who were upset with your test grade, a lot of the points didn't come from that. A lot of the points are from the multiple choice. So if you're unhappy and you want to do corrections, we're going to correct the multiple choice part. A lot of you guys didn't miss enough points here for us to warrant doing this. If you really want to do this, then talk to me and we'll work something out. So let's go ahead and go through these. It says 4.2, for the diagram, find the relationship between the number of shapes and the perimeter of the figure they form. Represent this relationship using a table, words, and equation. Each of those are 1 point. It says, what's the correct table for the diagram? So this is octagons. So it says number of shapes in the perimeter of the figure they form. That kind of is a clue there. So number of shapes should be first. So number of octagons. So 1, 2, 3 octagons. So it should have 1, 2, 3 for my first row. And then the perimeter of this first one is 8. For this next one, it's 14. Count it. 1, 2, 3, 4, 5, 6, 7. That's 7. And I know the rest of it's being cut off. 7 times 2, 14. So there's a shortcut for you. That works for 3 octagons. That pattern where you just cut off the last one continues on. So there is our pattern for this. And we have, now let's see, our table. So we can look at the table. I just eliminated out A and B about what we said. And if we follow C, it actually follows through the rest of the way. And we can count and double check. So 1 is C. Number 2, what's the correct choice for words in the diagram above? Here, they're very similar. You just need to notice that there's actually just a few things keywords that are different. Right here it says the perimeter increases by 6 units. This one increases by 8 units. And this one increases by 1 unit. So that tells me right away, okay, This one I'm looking at, it's got to be A because it talks about increasing by 6. So now I'm just going to check the rest. Shows octagons, okay. Starts with one octagon that has a perimeter of 8 units. Okay, that's okay. For each octagon you had, we said that was okay. The pattern's linear. So check, is the pattern linear? Yeah, because we're going up by 6 each time, so that does work. 6, 6, that's perfect. That's what we expect. 8 to 6 is 14, 14 to 6, 20, okay? To conclude, yeah, indefinitely, if you keep adding, yeah, if we kept adding more octagons, yeah, that would make sense. It goes up. So A works. So number 2 is A. Next one, number 3, what's the correct equation for the above diagram? We actually kind of just found that out because we said it increases by 6. So it would be y equals, 6 would be our rate of change. So then 6x, and then the last part, we have to find out what x would be at 0. So if I subtract 1 from here, that's 0. Subtract 6 from here, that's 2. So that leaves 3 as A. Y equals 6x plus 2. So we've just gone through 1 through 3. As we're going through this, if there's anything that comes up that you're like, man, I really didn't understand that, that's something that you want to put down for the end. If you notice, you do have a homework assignment today. It's a reflection piece. So there's a ownership. What did I do on this test? So that's going to be an ownership part. I'm going to hit as many of the problems as I can, but I want to make sure you also have enough time to write this in class because I want you to submit it today in class. Number 4 says, is the table for table 1 a linear or a nonlinear function? And so it's either linear or nonlinear. Well, if we developed a pattern that makes an equation and it fits, then it's linear. So because I'm going up by the same values for my y's, 6 each time, and I'm going up by 1s for my x's, then that means it's linear. If I graphed it on a graph, it would be linear. Oh, I totally do that for the wrong one. Is this a linear function? All right, so number 4. I was going way back up to here. All right, I should read my own test. So is the table for table 1. Here I am going all the way up at the top. We already did that problem. Table 1. Here, this is a nonlinear function. The reason it's nonlinear is because from 5 to 10 is 5, but from 10 to 10 is 0, 10 to 15 is 5. So even though we have this little hiccup right here, that makes it automatically nonlinear. Those of you who waited to come back to this later, when you graph it, you'll see that definitely the graph says that it's nonlinear. This says, what's the correct choice for table 1? And then this says, very unique pattern for input of 1, then your output of 5. And this says input of 1, output of 5. But then it says the pattern repeats, and then this one says the pattern is not repeating. And then this one down here says the input of 1, output of 5, and then pattern repeats in an odd way. So this going back, B is the only logical thing because the pattern doesn't repeat. Because it goes 5, 0, 5. If we were to follow that, then the next one would be 0, so we would expect the next one to be 0 as well, assuming that goes through. Sorry, my algebra is boring you. Oh, that's my wife. She's giving me moral support as I'm teaching you guys. So yeah, B is the logical one for that one. The next one, what's the correct equation that models table 1? This one is kind of like, well, if we can't have an equation because we can't have a pattern. So the pattern doesn't exist because it goes 5, 0, 5. There is no equation that can model table 1 correctly. So 6 is D. None of the choices are correct. There isn't a table that works. Number 7, what's the correct graph that models table 1? And I said that all graphs use input for x and output for y. So you turn to the back page and you see, okay, looking at this, well, this is a linear graph, so no, this can't be it. This is a nonlinear one, but this has values like 2, 15, 3, 12, 4, 18, so that can't be it. Going down to C, it goes 1, 5, 2, 10, 3, 10, 4, 15. This looks like it's it. Just to check this one's linear, so it's graph C. Graph C fits. Make sure I scroll the right one. So 7 is C. Jumping to the next one, table 2. It says, is the table for table 2 a linear or nonlinear function? So I see if there's a pattern from 10 to 20, 20 to 30, and 30 to 40. That's all going up by 10s. And my inputs, 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1. That would also work. So then my pattern is consistent between both. So then that would be a linear function. And then these are obviously incorrect. You guys pointed it out. Thank you so much, first hour. First hour. Words. I'm eating popcorn. The correct choice for table 2. The table listed for table 2 is amazing. The pattern starts with an input of 0 and obtains an output of 10. It increases for every 1 input. You add 5 to the output. So that tells me, all right, I have something wrong. So then at that point, I kind of look down the other ones. You add 10 to the output. So that one works. Down here it says add 10 to the input, you add 1 to the output. That tells me that's backwards. Can't have that. So B is the logical choice. Besides the table 1 is amazing part, which I said to change, B fits. So you would have B. Number 10, what's the correct equation that models table 2? So looking at this, for each number we have, it goes up by 10, so that automatically eliminates A and C, and then it actually shows you at 0, 10, so then B is the logical choice, because it fits. And then the last one for this particular problem, it says 11. What is the correct graph that models table 1? All graphs use input for x and output for y. So, again, this should say table 2, not table 1. So just kind of reviewing over this table real quick. 0, 1, 2, 3, 10, 20, 30, 40. So let's go back to here. Okay, that's at 0, 10. This one looks like it fits. This one doesn't. This one we used, and I don't think we're going to reuse them. This one, it kind of looks like it, but it doesn't start out at 0, 10, so D can't be it. So that eliminates down to A. So this is graph A. So now we're done with that problem. The next set is 4.3. This one where we start getting into some nonlinear stuff as well. It says graph the function shown by the table and then tell whether it's linear or nonlinear. Your review problem was about students in Algebra 1 class. That was actually true. Your review problem, those are my students in Algebra 1 class. These are not students in geometry classes because I only teach 2 geometry classes this year, and that's not enough to get a pattern. Incidentally, if you noticed on your homework and everything, you need at least 3 things to develop a pattern. So you've always had at least 3. I aim for more than 3, but 3 is generally the minimum amount you need to make a pattern. So for every class that I have, these are the number of students. So in one class I have 10, in this next class I have 15, this third class I have 12, 4 there's 18. There's really no pattern that happens here. That kind of gives me an indication that this is not going to be a linear. So just looking at it right now, I'm like, oh, that's not linear. So let's go check the graphs. Flip back here again. Oh, okay, definitely. This pattern, it goes up and then down and then up. It's not consistent. Some of you could probably say, hey, Mr. Brummond, but it is a pattern. Like it goes up by a number and then down by a number and then up by a number and then it could go down by the same number. That is a pattern, but that pattern is not linear, and that's important. Linear means that if I connect the first point to the last point, it makes a line. So if I connected this to this, I'm not going to hit those other points, so it doesn't work. So that would be graph. They are crafty. I made them myself. Graph B. That'd be graph B, and then I just said it's nonlinear. The next one, number of people in a parade versus how long the line is. So my x value line length in feet, 10, 20, 30, 40. So this one's different. I'm not going up by 1, and I wanted to show you that you can't. So that was the problem in the test, obviously, that you can go up by a different number, and that's okay. And we have that on one of the homework assignments. And then the number of people increases. So for every 10 x increases, I get a y increase of 15. Because I can say that, and I'm being consistent between all of them, then I know that it's a linear function. So I know automatically 15 is going to be A. Checking 14, it says what's the correct graph that models table 1? Again, this should be the table above. So going down, we really only have one graph left, so we just need to make sure it works. Graph D does work. That's good. That means we got all of our graphs correct. Feel more confident about that. So 14 is D, and then 15 would be A. And then we're going to end with this one. 16 says, what pattern can you use to complete the table? I think the easiest way to check this is to just plug in the different equations, unless you saw it right away. 1 to 2, 2 to 5, 3 to 10. At first it looks like I'm doubling. 1 to 2. I double that number, but then 2 to 4, I'm not doubling that number, so that's kind of odd. And 3, I'm definitely not doubling, so that doesn't work. So looking down here, this just says x plus 1, so take what x is and add 1. So 1 plus 1 is 2. 2 plus 1 is 3, so that doesn't work. The next one is 2x plus 1, so take this times 2 and then add 1. So 1 times 2 is 2 plus 1 is 3, so that one doesn't work. The last one, x squared, does work. You can check it. So if I did 4 times 4 would be 16, so that last missing value should be 17. 16 plus 1 is 17. So 16 is C. Those are good ways to check. Squared is an easy one that we've talked about before, so that's why I picked it for the test. So overall, we went through the test. We went through it rather quickly. I hope I highlighted a few of the things that you needed. What I would like for you to do is use this time now to write your paragraph you're going to open up a bit. And in that opening up part, you're going to admit, like, okay, what are some things that I did well? What are some things that I struggled with? What are some things that came easy for me? What are some things that I still need to learn? Like, even you going over it now, Mr. Brummond, I don't understand. So here's what I would like for you to do. If you notice you have a lot of time left in class, I want you to spend some time writing. So this is super important. Number one, your writing has to be legible. You're getting a grade for this reflection, so if I can't read it, I can't grade it. So that has an automatic grade of 0. And I want you to put some emotion behind your writing. So again, minimum of 5 sentences because you're making a new paragraph, but please feel free to put in more. You're going to be peer reviewing, so you're going to have someone else read it, and they're going to mark that they read it on that paper as well. So I have my paper. I'm going to write, over off the side, I put a prompt on the sideboard. Look at the sideboard. So those are some things to just kind of get you started. I expect you to have more than what just I have on the sideboard. Go farther. So put what you want on there, make it look good. You're going to be putting some emotion behind it, so be honest. I also, I need you to be mindful that these papers are going to be looked at by one of your peers. So you're going to look at someone else's paper in the room, and they're going to look at yours. At the very top, after you finish, you're going to put peer reviewed by, and then you're going to sign your name on someone else's paper. They're going to sign names on your paper. Keep in mind you may have to do a 3-way switch because I may have an odd number of students in the classroom, so just kind of be mindful of that. Or if you've already peer reviewed a paper, you may be asked to peer review another. So if you would, go ahead and write your paragraph. Self-reflection. The reason for the peer reviewing is that if there's something that doesn't make sense, let the person know. Say, hey, this doesn't make sense. Don't view it as they're attacking your writing. Think of it, they just want your writing to make sense. They want you to get a good grade. If they can't understand it, I'm not going to understand it. I want you to have a good grade. So that, in a sense, that's it. I really appreciate you guys. Thank you so much. Have a wonderful weekend. You see me, I don't see you, so wear your seatbelt and don't do drugs. Bye.